Up to this point, when we've talked about complex fractions, we said that a complex fraction is simply a combination of fractions. So, for example, in the pink here, I've got 1 over a, and then I have my main bar, and then I have a in the bottom, which really any number you can write it over 1, or any letter you could write it over 1. So this is what we call a complex fraction. And in this complex fraction, really you have a fraction on top, you got a fraction on the bottom, then the whole thing's really a fraction. Now, usually when we simplify these, there's two methods. One method is you could multiply the top and the bottom by the reciprocal of the bottom. So in doing so, if I take the reciprocal of the bottom, or the denominator, I have 1 over a. So I got to multiply the top by 1 over a. And in doing so, let's see, my a's cancel out. Everything in the bottom really cancels out. Now what I have left in the top then is multiplying across. I have 1 over a times a, or in other words 1 over a squared. And that's one way we could simplify those. Now another way that we can simplify this complex fraction is I could think of it as 1 over a divided by, because the bar means division, a over 1. And remember, when you divide fractions, it's the same thing as multiplying by the reciprocal of the second fraction. And notice that we get our same answer of 1 over a squared then. Now let's take a look at what we mean as far as continuing or more on complex. In example 1, I've got another complex fraction. But the only difference is if I look at the main bar, and the main bar being this, really I'm adding fractions on the top, which we haven't done before, and then on the bottom we've got another fraction. So I have a complex fraction, but to simplify it, we got to do a little bit more with it. So the golden rule, and there's a few golden rules in math, but one golden rule is whenever you have that main division bar, simplify the top of it, simplify the bottom of it. So in the top, I need to add those fractions. So I'm going to take 1 over w, and I'm going to add c over w. And really, I don't need to write that out, because when you add 1 over w plus c over w, when you add or subtract fractions, you want a common denominator. And notice I do have a common denominator. So my common denominator is w, and then you simply add the numerator, so 1 plus c. So in the top, really what I have is 1 plus c over w, and then the bottom I have my 1 over c. Now it's strictly just a fraction over a fraction. So I have a fraction over a fraction. So I do what we did at the beginning on the previous screen. You multiply the top and the bottom by the reciprocal of the bottom. Remember that one method. And in doing so, everything cancels out in the bottom. In the top then, what do I have left? Well, I have, and I'm going to try to squeeze this in right here. So multiply the w times 1 is w. And then I have c times, and remember this is one value, that's a couple. So I have c times that 1 plus c, like so. Now if you want to distribute out the top, let's see, c times 1 is c, plus c times c is c squared over w. So really you could leave it like this, or you could write it like this. All right, let's take a look at example 2. This time I'm adding fractions on top, because really, remember, 5 is the same thing as 5 over 1, and I'm adding fractions in the bottom. So how do we do this? Well, you add the fractions in the top, and you subtract the fractions in the bottom, because notice they're subtracting. So in the red here, I'm going to take 1 over m, and I'm going to add to it 5 over 1. So I'm going to find my common denominator, which is the least common multiple. So what's the common denominator for m and 1, or the least common multiple? Well, it's m. So now I ask myself, let's see, m times what is m? Well, 1, so I got to multiply the top by 1. And in the bottom, 1 times what gives me m? Well, I'd have to multiply m, or 1 times m to get m. So I got to multiply the top by m, and that gives me 5m. So in the top now, I have, so I'm adding these. I have 1 plus 5m over m after I add those two fractions. Now I need to do the same thing in the bottom. I need to take 2 over m and subtract x over m. Now here, again, I didn't really need to line this up because I have a common denominator. I have m. So so what is 2 over m minus x over m? Well, it's going to be 2 minus x over your common denominator of m. All right? So now we have a fraction over a fraction. So how do you simplify that? Well, you multiply the top and the bottom by the reciprocal of the bottom. So times m over 2 minus x. And I need to do that in the top also. So m over 2 minus x. Now on the bottom, these cancel. This couple cancels out, right? Because I have a 2 minus x and a 2 minus x. In the top, I can cross cancel the m's out. So what do I have left now in the top? I have 1 plus 5m over the couple of 2 minus x. And I'm done. Okay, last example. Now we have some negative exponents. Now, do we have a complex fraction here? Really, we do. Because I could rewrite this as a over, drop the x to the negative 1 down, it becomes x to the first, plus b, leave the b to the first up there, which remember, b is b to the first, drop my y to the negative 1 down, it becomes y. And notice that I'm keeping these things really above this main bar, right? I'm keeping everything that was above the main bar, it stays above the main bar. Maybe the phrase you've heard, what happens in Vegas stays in Vegas. Well, however you want to remember this. Now on the bottom, the x to the negative 1, well, keep it in the bottom, but create a fraction out of it. So it's 1 over x to the first, or 1 over x. So that may be a little confusing, but maybe the best way to remember it is what's above that main bar stays above it, and we drop those negative exponents down, and below the bar I create a fraction below the bar. Now let's simplify this. So let's add my a plus x and my b over y. My common denominator is xy, or in other words, the least common multiple. So x times what gives me xy? Well, I got to multiply by y. So I have to multiply the top by y. In the bottom, y times what is xy? Well, times x. So I have to multiply the top by x. So what do I have now? And in the blue, I'm going to continue this problem. So above the main bar, I have, let's see, I'm adding the fractions, right? ay plus bx over xy. I'll make my y a little more clear there. Over 1 over x. Now we have a fraction over a fraction. So I multiply the top and the bottom by the reciprocal of the bottom. And in doing so, everything in the bottom cancels. Now, I can cancel out my x's here, because even though I can, as long as if I'm multiplying, I can cancel out part of that product. Maybe an example of that would be if I had, say 2 times 3 over 2. Okay, I can cancel those out. Because if I simplify 2 times 3 is 6, 6 over 2, I get 3. As long as you're multiplying, you can cancel them out, which I did. Now, that's all I have left, right? So my answer then is simply the ay plus the bx over my y. And I'm done. All right, so this is just a little bit more on complex fractions. And the main idea here is if there's any work to be done above the main bar, you got to do that. If there's any work to be done below the main bar, you have to do that. And then simplify the complex fractions like we've always been doing.